So I think we can all start. We said, welcome first to the session on natural resources in a changing climate, with a focus on agriculture and forestry. So my name is Annette Schneegans from DG Agriculture of the European Commission. And this session is just an hour, so it will be very, very brief introduction into getting to the substance of what we want to tackle in Horizon Europe in relation to the topic of natural resources, get your views on what we think we're proposing, and of course also hear about your ideas, any ones you have, either because you already voiced them in consultations or because this is the first time you have the chance to do so. The resources we will be looking at are water, nutrients, and I would say wider ecosystem services, including biodiversity in forestry. It's not about soils, because soils we have dealt with quite in detail in other sessions on the soil mission. So this is why we only have these three issues here. This conference and your input come at a very crucial moment, because as you may know, we are now in between the legal basis and the strategic programming. And the strategic programming will be the basis for the specific topics that we will publish later. So, just to set the scene, agricultural research and forestry research are within what we call Cluster 6 under global challenges. And under this Cluster 6 is a specific intervention area for agriculture, forestry in rural areas. And when developing the precursor of the strategic programming, we identified 6 major impacts. So these are not in the legal basis. These are in the back of the strategic programming. So you will see some impacts relating to climate change, to biodiversity, to natural resources, which will be the focus of today's session. And then we have primary production systems, food systems, non-food systems, or how do we manage to produce. And then we have rural development and governance models. So today is about natural resources, and of course they link up with the other themes. When talking about natural resources, we'll be looking at climate. And this is the nexus we want to take today, the nexus between natural resources and climate. So with this, I would like you to introduce 3 speakers that will set the scene. First of all, we will start with Elena Gomez Macpherson from CSIC in Spain. And Elena will tackle water regimes, water quality, and the water cycle. The floor is to you, Elena.
Thank you very much. And thanks also for inviting me to introduce this topic. I only have 8 minutes, and it's difficult to think what to say. So I decided to pass to you the main results of different discussion groups on water under climate change and how that and the importance of management around it. And these groups are not only researchers, but also include farmers, agro-business, advisors. So in a way, it brings the view of the side of the more of the users, one could say. And so most of the discussions, we can say that on one hand address how to improve and increase as much as possible water availability for the farming, how to use that water efficiently, and how to improve resilience until variable climate that we are facing. And all these protecting the water and reusing it, minimizing the degradation. Now, for the first one on how to make the most water available for the system, the main thing is to grow when you have rainfall, to have crops when you have rainfall. But for improving the the use, the total quantity, it's important to have an increase in filtration of the water. So what you want to do is to reduce as much as possible the losses of that rainfall. For that, for example, one could say, okay, not to till, cover the soil. You can improve your infiltration, and but at the same time, you can have a problem with higher risk on lixiviation of nutrients. So we need to understand this trade-off of elements to take good decisions. So have models that help you to understand how is this interaction. The same when we go to how to use water efficiently. I mean, there are strategies that takes you in one direction or the other. And we need to understand this trade-off. Remember, sometimes technology that improves your water availability at the same time increase your risk of contamination. When we are in the in irrigated agriculture, it is clear that we have to. Efficiency is a word that it's so commonly used and here, no? Because there has been a lot of effort on improving the efficiency of irrigation and the irrigated agriculture. Now, with the new and better weather data and models, there are already decision support systems that help us to programming irrigation and minimize that lixiviation or percolation. Now, there are although they are commercially available, I mean, there's still a window to improve it. For example, there are now plenty of plant sensor or soil sensor that help to improve the knowing how much water is in the crop and how much I have to give to not to stress. Now, these sensors are often expensive. Sometimes they are not clearly how to distribute it. So there is still need to improve this. Similarly, we have now better images, remote sensing images that provide. We can use it for a lot of indexes, again, to estimate the water in the crop. Now, there are many indexes, and it's already used, but there is still need to understand the physiology behind those indexes. So we can translate from one side to other its use. Now, the images also are used for precision agriculture. Here, we found this paradox of having very nice images that we don't really understand what's behind. My point is, you get areas with good crops, area with poor crop. Now, with the poor, what do? Do you give more water or give less water? You don't know, because an image doesn't tell you really what's behind that low crop that you are seeing in your image. So we've gone through efficiency. Now for resilience. How you can improve resilience in a diverse system and reduce as much as possible the risk. The general view of the groups is that as you have more diverse agriculture system, you can have a diversification of risk and confront it and be in better situation. Well, there's also an obvious issue, that is you can have insurance, and that covers you for some part of the variability. But these insurances, these companies will need tools again, to understand probabilities and variability and risk associated to the system. Now, for the quality and the reuse of water, again, we should consider the main problem the user face is really not knowing exactly what's the impact of different options, of different strategies, of different systems. And I would say that's general for a lot of people. If one farmer adopts a new technology, there is not really an explanation or not really a tool that gives or tells them how much is the impact, not only on the kilos, because that he counts and he can see, but on the environmental issues, on the quality of the water, how much you are lixiviating. For example, if we have these decision support systems that are already used for water and can be used also for crop management and fertilization management, then we could also, this system, they should provide as well an indication of risk related to the environment. And for example, for nitrogen balances, it can provide the risk of having lixiviation. And let me also to related to the protection of the water, because of the nature of the water, it is important to understand that we need a better understanding of the interaction across the scales. One effort at the plot scale means nothing if you don't have a general understanding and a general effort for higher scales. And just for finishing, one major complaint of users is that a lot of these technologies that are available or that they promise that they are good for conserving water, the reality is that often they don't know the effectiveness at farm. Often they are not that effective when they go to commercial conditions, and also the economic return is not clear. So buying a lot of sensors might not be really effective or might not even imply that the farmer is in better conditions. And I think with that I finished.
Thank you very much, Elena. So Elena touched on many issues on water use efficiency, resilience, and the various scales of water use. Please keep all your questions until the end, until all the three presentations. You have also the possibility to draft some Slido questions. You should have received some instructions over there. So keep this then for the end. We will move now from water to forest systems. And Georg Winkel from the Forest Research Institute, European Forest Institute, will talk about ecosystem services of forests in relation to natural resources.
Okay, thank you. Thanks for the nice introduction. It's a great pleasure to be here. I have to admit I can hardly see you, and we all can hardly see you because of the spotlight, but I'm assuming that you're still in the room. So I have been thinking what to do with the topic, and I put 3 questions down I would like to shortly address. So first, where are we with forest ecosystem services and natural resource management in Europe? So what do we know? Second, what are key challenges? And third, what could research do to tackle them? First question, forests cover about 33% of Europe. I think this is interesting for many of you that are not coming from the forest world in Europe. Most of them, more than 90%, are managed, and about 60% are privately owned, just to set the basic stage. They are significantly important for societal, economic, and ecological reasons. Just to give you 5 spotlights, because it's not easy to talk about everything in the 8 minutes. Climate change, forests and forest products are seen as sequestering about 13% of the anthropogenic greenhouse gas emissions in the EU, but there's also an increasing adaptation pressure with strong regional differences. Secondly, forests are crucially important for biodiversity. About 23% of them are under Natura 2000 network, and there are some signs of pressure on forest biodiversity, even so it's usually not as worse as in agricultural lands. Bioeconomy, forest and the forest sector, it's very hard to really estimate the full economic importance. I came across figures of about 486 billion turnover, more than 3 million employees, and about 16 million forest owners. So there's a huge already used potential, but also a huge potential for the future going away from fossil resources. Fourth, non-wood forest product, there's really interesting recent research that shows that about 26% of the European households, that's quite massive, collect at least once a year non-wood forest products. It was within the FP7 Star Tree project. And they create a total economic value from these non-wood forest products of about 23.3 billion, which is equivalent to 70% of the economic value of roundwood removals. And a lot of this is not on formal markets. And fourth, there's some interesting developments. Fifth, I'm issues with counting. There's an interesting development relating to societies and forests. They're changing societal demands, urbanization processes. Cultural ecosystem services are booming a bit in the forest world. So for instance, today there are in Germany about more than 2,000 forest kindergartens. When I studied forestry about 18 years ago, there was hardly anyone. And we have an EU project called Sincere, where we look also into so-called funeral forests, where forest owners start to give a part of their forest as a kind of spiritual funeral place. And this is, again, you could say, a booming business model with more than 100 of those alone in Switzerland. But there are, in all of that, quite strong regional differences. Second question, so what are the key challenges with this? This is all fantastic, you might say. Well, there are perhaps 3 challenges I would like to emphasize a bit. First of all, there are synergies, but there are also important trade-offs between all these good things forestry can do for society, between forest-related ecosystem services. In the end, you could say there are very different human desires and needs towards forest, and there's a challenge how to deal with them in forest governance and forest-related management. So to give 2 examples, there's frequently a trade-off when it comes to or a relationship that has to be investigated close by research between biodiversity issues and forest biomass production. There are many synergies and interesting management approaches, but there are trade-offs. There's possibly also a challenge when it comes to the highlighted important function forests have for climate change mitigation, when on the other hand, there's more and more adaptation pressure on forest disturbances, which has to be carefully analyzed. Second, some of the key drivers that we currently observe might go in different directions. Just to mention one thing, I see a colleague of mine sitting in a room working in a big nature-based solution project where the issue is urban forestry, urban nature-based solution. So urbanization puts new demands on forest ecosystems on the one hand, but urban lifestyles also put very traditional demands on more and more forest-related resources. So the big question is how to bring this together, urban lifestyle, urban need, urban consumption with forest management in Europe. And third, there's something that I would like to call there is no splendid European isolation. So there is a strong connection in all forest-related issues, forest ecosystem-related issues to other continents. We all know the climate change challenge, which is regionally quite distinct, but still is a global challenge. But also there are issues like trade connections, consumption connections, for instance, relating European markets to tropical deforestation. Mm-hmm. Last question, what can research do to tackle this? And I have 6 action points. First of all, I think there's still a need to go deeper into a full assessment of the forest ecosystem services value of Europe's forests, looking at the demand side and the provision side. So basically coming from the natural sciences modeling perspective, from the trees, so to say, but also coming from society to understand better societal demands and needs, the ones that they can utter, but also the indirect ones, the needs for resources and material. Second, there's a necessity to provide a comprehensive and transparent analysis of synergies and trade-offs between these forest ecosystem services. On one hand, at larger scale, but also in very concrete scales, in very different cases, to really look into where are the synergies. There's a lot of work done on that, but there's still a need to more systematically go across disciplines there. There's an urgent need to understand change relating to forestry. Climate change is very high on the agenda for good reasons. There's some quite dramatic development in parts of Europe at the moment, and there's a need perhaps to come a bit beyond modeling to empirical research to now understand how are trees reacting to extraordinary heat waves. But also there's a need, in my view, to integrate forest users, forest managers, nature conservationists, and their experiences, let's say the soft knowledge, to bring it together with the hard science, a bit going in this farmers integration direction. Third last point, I think there's also the need in some cases to break up some science silos. To give you one example, we did an initiative where we looked into a very contested forest, Białowieża forest in Poland, where there's no agreement also between different science communities. And what we tried there is to bridge different communities, conservation, biologists, economists, social scientists, to force them together 3 days basically in a cabin in that forest and to discuss intensively what is the controversy actually about, what does science know, where's an agreement and where's a disagreement. And I think it could be a perfect tool also to think in research about these type of assessments, building on existing knowledge, exploring what do we really know, where's scientific agreement, and where's scientific disagreement, and what is simply a political question. Their second last point, a need to work at the science-practice interface is especially, I think, to be observed in countries where people don't speak English, and in the future, likely in the EU, not more than many countries left where English is spoken, between those that really work in forest practice, in agricultural practices, and the scientific community, participatory research, citizen science, co-design. Last point, I think it's important to highlight that Europe is not alone, and there's more and more need, if you look at the economic importance of different big markets, if you look at the intellectual importance of countries like China and so on, what's happening there, to really go for this cross-continental research collaboration, and perhaps even let scientists work as science diplomats to really understand how does the Chinese research community approach forest and agricultural issues, what's happening in the US, what's happening in these big forest countries in the global south. And it would be very good if research would more and more encourage really this transcontinental collaboration. I saw 1 minute, so I could actually continue, but I have nothing more on my paper. Thank you.
So thanks so much. So this gives me 1 minute now to comment a bit, because it was incredibly rich 7 minutes, where we, I think, got very good grasp of just with few statistics about what forests are in a sort of new way. We heard about, I think it was nice to highlight the global dimension of research. We're here to talk about European Horizon Europe program, but of course we need to go beyond Europe, and the global dimension is key. I would like to highlight one thing that we will come maybe across later in discussions is, you mentioned a lot participatory research, getting science practice interfaces. This is something that we're quite used to in Horizon 2020 through the multi-actor approach and in team with the European Innovation Partnership, agriculture. But there could be an EIP Agri where forest is even more present. So that's something just to add. Now, again, keep this in mind, and we'll come back with questions afterwards. I'd like to introduce the last contribution today on nutrients. And Erik Meers from University of Ghent will tell us a bit how to improve the loops and the closing these loops between nutrients. And he does it normally in a very integrated way.
I had a presentation. Yes, there it is. Yes. The previous speaker had a very nicely typed out questions and answers, which at first, when he was starting with the questions, had me worried a little bit. I thought maybe I missed something and I have to go through the existing questions there. But no, every topic has its own, of course. For nutrient recycling, a little bit of an insight. So I'm from Ghent University and involved as coordinator in various projects, amongst which also Nutrient Recycle, and maybe the next slide, please. Yes, and I'm also the promoter of 3 platforms. I will not discuss all of them because then I would eat up my 8 minutes without telling about nutrients. There are 3 platforms, and I think the slides are not so. It's very counterintuitive to talk about slides there. There are 3 platforms. You have one which is on collaboration between European projects, and that's the one that you can read the least. That's the one on the top left, and I will tell you a little bit about that, Biorefined Cluster. I will omit the other twos. The End of Waste platform is a business development platform, so it's around orientation for the circular economy, but towards business stakeholders. And the bottom one, Infinity, is a scientific network that households various Marie Curies and other scientific networks, both within Europe, but also outside, linking to Asia, North America, and so on. But next slide, please, because I do not want to talk too much about non-nutrient things. This is one thing that I would like to highlight. This is because I think it's most topical for today. The BioRefine Cluster Europe is one of those 3 platforms, and that's a platform which is about interacting between European projects on biomass. And actually, we start a little bit from, hence the name, we start a little bit from the conventional petrochemical refinery concept, and you say, okay, we have all these nasty fossil resources, but we turn them into nice things like energy for one, but also synthetics, chemicals, and so on. And we want, in our view, also do the same, but in a new kind of economic setting, and a new economic frame based on biomass. And then you can also have these various values that you can extract from it. Energy, yes, in its various forms, gas, heat, power. Also fibers towards things like biocomposites and materials. Water you can extract. Biomass contains a lot of water. That means also you have processing water when processing biomass, and so on. You can extract some target molecules, some bioactive compounds that you can extract. And last but not least, and the topic for today, actually also nutrient recovery, and it is an upcoming and increasing topic. When I started with nutrient recovery technologies and implementations in agriculture and beyond agriculture, it was more of a novelty, but now it's getting more and more mainstream, which is only a good development. If you are interested about BioRefine Cluster, there are now about 30 European projects which are collaborating on different topics. You can just go to biorefine.eu. It's very easy to remember, biorefine.eu. And that takes me to the next and most important slide for today. Well, the nutrient cycling throughout the agro-ecosphere. When a few years ago, people from the European Commission asked me how we could reconnect the nutrient flows that exist between the plant production and the animal production, well, we responded as an expert group that was, and they proposed to reinforce mixed farming, which is nice. There are a lot of mixed farming models out there in Europe. But we said, okay, but with mixed farming alone, you will not make that loop closed. At the moment, we have this, which we call a nutrient paradox, in which from one end we are using consistently more and more mineral nutrients and mineral nutrient fertilizers in plant production to increase our productivity, our efficiency, and our capacity to feed our growing population. So those chemical fertilizers are on one hand based on fossil resources like natural gas for a large extent when we are using them to make nitrogen fertilizers, or they are based on finite phosphate rock deposits, so by excavation and mining. And moreover, those phosphate rock deposits and reserves are not in Europe. There are only scarcely some resources to be found in the outskirts of Finland. That's basically it. All the rest we have to import. So that means it's coming from China, North Africa, Middle East, and North America. But other than that, we're completely dependent for our own phosphorus imports. So that makes us quite vulnerable geopolitically as well. And of course, all these uses of primary resources to feed our agriculture, well, that's a problem. At the same time, also at the animal production side, we have a lot of import on nutrients when we are thinking about intensive livestock. We are importing vast amounts of protein sources from South America, like soybean, to feed our growing appetite for meat. That is, and that means that, again, there you're also importing nutrients. And the nutrient paradox lies in this, that we have all these, because of that, nutrient pressure regions where we have livestock in abundance, manure aplenty. We actually have 1.8 billion tons of manure each year in Europe. That's an ocean of manure that you can consider. while we are still continuing to increase the production of primary resource-based nutrients as well. So that's the paradox. We have a lot of it in organic form, and we also create more in chemical form. The paradox, like we said then a couple of years ago in various commissions to the European Commission, including the focus group on nutrient recycling, was, well, in order to solve this paradox, you do not need to reconnect, because the reason why, not reconnect directly via mixed farming, I have to be complete, because there's a reason why plant production and animal production, in essence, have diverged in their productivity increase. So there is a reason why this occurred. This did not happen overnight. So in that sense, we said, okay, on one hand, we have nutrient abundance, which is putting pressure on environment. On the other hand, we do have requirements for nutrients to feed our agriculture. So in order to make things work, you have to invest in a third pillar. So what we call the agro-processing, and that's that third part of the triangle, that we say, okay, things that are in excess coming either from plant or animal production, you need to invest in ways to process and upcycle nutrients back to their mineral chemical form, so that you can substitute the dependency on primary resources either for energy or for the nutrient production themselves. So, and in this overview, you can see various ways of going about that. So you have residues coming, for example, from animal manure. You can go to biogas. In biogas, you can create digestate. Digestate already has a higher nutrient use availability than original animal manures. But we also have a lot of European projects which are investing in further upcycling digestate and nutrients from digestate and purifying it into really formulatable forms. So there's a lot of technology development on the processing side. You also have, okay, I have to wrap up. You also have new things like novel animal feeds and novel protein sources, which can replace our dependency on import. We also have research lines which are investing more and more in dealing with precision fertilization and application, and looking, okay, we are dealing with the reality that we have a lot of variable bio-based organic fertilizing products, but in order to optimize efficiency and plant uptake and thereby reduce the losses to the environment, well, there is a lot of technology also investing in precision farming and smart farming. So, well, I will not go into each of these research lines. The projects that I put there are just a few of the biorefined cluster that I'm also involved with. Nutri2Cycle is one that's dealing with this triangle and dedicating 24 different research lines. Renew2Farm is linking into associated partners who have actual business plans that want to recover nutrients from different sources, including, by the way, from outside of agriculture. You also have waste processing, municipal wastewater, and so on, where you can extract nutrients from. And Nutrimon is developing a network on market-ready technology. So those are 3 projects that are also working on this topic. So that means I will wrap up at the moment, as I've indicated my sign. Next slide, please, which is just the question for questions. And maybe if you want to look, you can look at follow us on Twitter. There is also, of course, my email address if you want to ask me questions afterwards. And at the bottom, we also have the Biorefined Bulletin, which is monthly, and we give updates on projects as they occur. Thank you very much.
Thank you very much, Eric. So Eric actually introduced in his presentation the regional and cross-sectoral dimension to nutrient management in agriculture. We will have to look beyond agriculture to what you call the third sector, in a way, which is what we call a provisioning sector or intermediate, to develop value out of byproducts. And ideally, at some point, we don't talk about waste, but about byproducts and how we can increase value to then feed back into the different loops. So we have heard 3 presentations, all of course very different, tackling different issues. They have all in common that I think they've shown you the complexity of dealing with these nutrients or water or broader ecosystem services in agriculture and forestry. And what we would like to do now in the next, we have 15 minutes, 10 minutes, 15 minutes, is either your feedback to some of the issues, your questions, but also where you think that you would like to add something. Because, of course, we couldn't cover everything in 80 minutes. So colleagues will help you with the microphone, and so please, this is now your session. Thank you.
John Bell, Alea, all European academies. Gail very helpfully identified lots of contributions from social sciences and indeed humanities. And I guess one of the questions to you all is, what are the effects of the different technologies that you've been talking about on the kinds of community that work around agricultural forestry? Does it mean that you need different types of population and people working there? Because one of the things that we see in many agricultural communities now is almost no workers, because machines have taken over large farms and so on. And many activities are focused on solar power and so on as replacements for agricultural activity.
I suggest we take 2 or 3 questions and then we go back to the speakers.
Thank you very much. Rosa Mosquera from the University of Santiago de Compostela. I just like to make 2 questions, if I
sure.
may. One is for the first 2 speakers, because they were speaking about water quality and also about agriculture and forestry, mainly forestry. I would like to know what do you think would be the role of agroforestry as a way or a tool to increase quality of water, and what could be the role on forest systems all across Europe? And for the second one, they puts already agroforestry in the system, I saw that. But my question is about processing. I like your idea that saying there is a real motive, a real reason behind of the separation between livestock and cropland systems. But it's true that processing could be taken into account at different scales. And if the scale is too big, it means that you have to spend a lot of materials to transport to the livestock and animal farms. So my question is, when we are thinking about processing, what is the scale you mean? Thank you very much.
Okay. Is there a third one we can take? Yes.
Hello, I'm Denis Lacroix from Foresight Analysis at the Ifremer Institute about marine sciences. My question is dealing with climate change. I was surprised by the fact that it had been mentioned very little in your presentation. And yesterday we had a presentation of the evolution of the cryosphere on the Earth, and we are expecting to have a sea level rise of approximately 1 meter at the end of the century, which implies salinization of a lot of coastal areas in which you have very active agriculture. So how are you preparing this shift, which is very rapid when you consider the evolution of the production system, notably in Europe?
So I would suggest that you start. Why don't we start with the last one, to set the scene on climate change, which was at the beginning of the session title, and then we move to the other 2. Who would like to start with? Maybe the foresters?
Yeah, the foresters. Yeah, I mean, it's a big issue. It's a really big issue. Perhaps that's why I have been mentioning it not so much, because it's anyhow big. Everyone is aware of it. It's for forests. Forestry is, I think, a specific challenge because of the long duration of all the ecological cycles, but also the economic cycles in forestry. And I think it is important in 2 regards. On one hand, I mentioned this contribution of forests and forestry to mitigation, but at the same time, the increasingly alarming question of adaptation. And this year and last year, we had big disturbances. They're very contested in their nature, bark beetle colligations, forest fires in the south. That also put questions to the climate mitigation function in the future. We did some research showing that empirical social research, that in the north, forest managers were quite confident, while in Central Europe, they are now very alarmed in the south, they have been alarmed since quite some time. So I think there's clearly, it is now the time, if you want, scientists are a bit the winners of a bad situation, but now is the time you can really research on old trees. How do they respond to pressure? And I think there's an urgent need to do this. And there were some bad surprises in the last 2 years when I talked to my colleagues in the natural sciences about how heavily climate change has affected some of the old trees. I stop here, but it's a big topic. I would also add one sentence. It's also there's a fight between different scientists about what is the best way of dealing with forests in Europe in terms of climate mitigation as well as adaptation. And that might be also a point where it would be very beneficial to force different scientific communities to work together and to clarify what do we really know and where are we speculating or following the things we think we would like to know.
If I can add on water, I didn't say because I assume that everybody is conscious that how important it is for water, in the sense that we already have large areas in Europe suffering scarcity, and that's going to be worse, maybe less in the north. But for the south, there is already hotspots that are suffering already water scarcity plus the rise on temperature. That means the water demand will be much higher. Therefore, it is for this that it's not new. It's already decades that we have been working in the south already on improving irrigation and how to make it more efficient. And in the case of irrigation, what is happening also in terms for the energy, it's a boom on solar power for the energy used for irrigation, trying to use more clean energy. What's the paradox? That we are getting systems modernized that are now more efficient to irrigate, to use the water, and the energy now is cheaper with the solar, and that is not really resulting in more water conservation, but maybe an expansion of irrigation surface. So we have this paradox that we also have to work well, but certainly for water it's clear, no? It's already there, one could say.
Yeah. And how is it impacting nutrient cycling?
Yeah, absolutely. We didn't dive into it because indeed in 8 minutes it's quite short. But it is clear that climate change is both impacting agriculture by floods, droughts, and so on, but also the other way around, that agriculture is impacting the climate change. How optimizing nutrient cycles could help out is in the agro-processing, for example, either at farm scale or at larger scale. You have a lot of renewable energy developments based on biogas and associated technologies. But that's not the only gain in climate change. You also have, if you process manure, for example, rather than storing it, but processing it quite fresh, you have a lot of potential avoidance of methane emissions from storage, which is a large contributor to climate change. The drive towards circularity in nutrients. To give one idea, the mineral nitrogen used throughout the world is responsible for percentage rates. So 1 to 2% of the total global energy consumption is linked to one chemical process, being Haber-Bosch, which means getting nitrogen from the atmosphere, using natural gas to convert it in mineral nitrogen for fertilization. That's a huge impact already on the global energy. So already making that sort of circuit and upcycling recycled nitrogen to replace fossil resource-based nitrogen fertilizer is also a big gain. And the same goes actually for primary phosphate rock being excavated and being replaced by circular counterparts. Also that will help combat climate change.
Yeah. Okay, and what is now, so the question was related, I think this was John Bell, asking about socioeconomic drivers on employment. I think it was more for Eric, isn't it?
I think it was also relating to forestry, but I'll take us first, it's no problem. Indeed, it's a very interesting question, and in our various projects, we are also now diving deeper in what we call the human factor from two angles. On one end, developing things like social LCA, so how is the impact of different innovations on the social fiber and social dimensions. But the second one is also how are end users and the society at large influenced influencing decisions up the value chain. Up to now, we have just been looking at technical innovations, agronomic innovations, but not been considering the society itself as a driver or a puller of innovation. And one of those projects we are also investigating the human factor, in the sense, for example, there is a big awareness growing in consumers using labels, sustainability labels and things like that, and that might be a way to also influence. It is about animal welfare and things like that you have currently labels, but things like nutrient recycling, well, I don't think at the moment that we know, because we held a workshop on it with a lot of stakeholders, that there is at the moment no criteria that's also taking that into account. Nonetheless, both retail and labeling organizations are taking an interest in saying, okay, that might be the next step on sustainability criteria.
Anything to add to this?
From the tree side?
Yes. Otherwise, you had two forest-related questions.
Okay.
I think this one to you.
Well, quickly, yes, I think it's a big question, and I think it's also a question where it's very interesting to collaborate with agriculture. Some of the keywords that I hear when I talk to agricultural scientists, like precision farming, it is really interesting to make this connection across the sectors and to understand what is happening in agriculture, what is happening in forestry, what are also, let's say, the societal economic implications of digitalization. Imagine fully automatized harvesting machines running around in forests. How is this perceived by society? I mean, technology is there, I would think. One thing I want to highlight with technology also is transparency. I know the Stockholm Environment Institute are working on this, that you can trace global trade with basically all agricultural and forest products, and it's simply fascinating. You can more or less, I don't know if they are already there, but if they are there, you can understand, so where's this soy thing I'm buying, where's it coming from? Has there been 2 trees cut? I'm making it a bit up here. So I think there's a big chance through technology to also go for involving research, making transparency between consumers and markets, and helping companies that want to act sustainable to prove sustainability impacts. I leave it with that.
Okay. So I think we are for second round of questions. If there are
I
any?
think those questions were not answered yet.
Agroforestry.
Mark, you're not totally happy? If you could answer, it was on...
I am happy with the definition.
Yeah?
Actually, yeah.
Okay.
But again, forest and water, I mean, it would be interesting to ask her about it. I think as a forester...
The problem of the scale.
Yes. Okay.
For
So is it-
agroforestry, certainly we know examples already where there is a clear role for improving the quality of the water. And it's, I think it's a matter of management and understanding, let's say, the transparency also, understanding the impact of the systems, quantifying how much will improve or make it neutral. But in our case, we know cases that for sure have a role.
And there's a lot of research on that, also historically. And the findings are not always total. It depends a lot what type of forest, what type of management. Is it quality or quantity? I think there's a lot out there. But again, it changes now with climate change. Things that were researched on Central Europe, I'm not sure how we evaluate them in the future.
And on a scale towards agricultural systems and nutrients, well, we have, actually there's no right or wrong answer on what should be the scale, because in industrialized regions like in Flanders, you have actually there as well both the large and small scale. We have projects which, for example, are processing 180,000 tons of digistate and having investments on upcycling and refining. That's centralized refinery concept, but we also have on the other end we have individual farmers, cattle growers with only a cogen engine processing up to 10 kilowatt electricity, which is very small, and the gain there is that the farmer uses his own manure, not dependent on others, and producing his own energy, reducing his external costs, and mitigating his own methane emissions. So that's you can have benefits both at small and at large scale. And also, by the way, on mixed farming, because I went into agro-processing because that's what I'm used to. But in the project, we also have a lot of mixed farming systems and agroforestry concepts that try to make the link between local animal production. For example, just out of my head, I remember a case in which they are combining orchards with geese production and also recycling the manure from the geese for the orchard and so on, and also using it as running grounds for the geese. So there are a lot of, and that's just one that just pops up of my mind. So it's not a model, but it's just so, and there as well you have a gain on local cycles. So there is no right or wrong scale. I think it's you have, as long as the model fits both economic, social, and environmental, and agronomic, of course, then it's good regardless of scale.
Yeah. So I think we can have 2 last questions. Sure.
Hello, I'm Bram Moeskaps from TB Organics. I have a question about nutrient recycling. In the previous panel, we spoke about carbon farming and the need to store, sequestrate carbon into the soil. And my question is, how comes nutrient recycling there? Because you usually separate the nutrients from the carbon, and you only bring the nutrients back to the soil. And how then can we improve carbon contents in the soil?
That's an excellent question. And in our cycle, and actually in Nutri2 cycle, for example, we look at nitrogen, phosphorus, and carbon. And indeed, there has been an overemphasis in all legislative frameworks focusing on nitrogen and phosphorus, and using some of these as limiting elements for how much you can spread. Problem is, in a lot of countries you have now phosphorus as a limiting element, which means that by default farmers are going to indeed separate and upcycle and refine and get the pure nutrients out, but not returning sufficiently also the organic matter. And organic matter and carbon indeed has a soil sequestration function on one hand, but of course also soil fertility and soil structure to it. And we do have a dedicated research line which also is focusing, okay, what about strategies for recycling organic carbon on top of the nutrients, and not just have a one set mind on the minerals itself. So it is indeed a good question.
I think there was here one question by Niels, and the last one maybe by you. First maybe for the lady, and then we come to Niels.
Hello, my name's Elaine Grum from the Agri-Food and Bioscience Institute in UK. My question's for Eric, and it's also about nutrient cycling. There has been a lot of investment in research, and you have described very well the excellent all scales of cycling. You have examples in Flanders. But what, in your opinion, is the major barrier that exists or remains in widespread uptake of these technologies?
Well, can we take just Niels? And then, so we'll have the last 2 ones, and then you can think about who answers the second one.
Thank you. Okay, so I'm Niels Heilberg from Aarhus University. This is for Eric and for you from Spain. Sorry, I forgot your name. Now, it's about the potential you might see or not for moving into or changing our current annual cropping systems, which are widespread, into using more perennial crops based on the different assumptions that you gave. So let me just briefly explain. I mean, we heard yesterday also from Dr. Kreiser that biomass on a European level will be really in high demand and potentially limited. So we should look at ways to produce more biomass for all different purposes. It fits nice with your biorefinery process that we also work with at Aarhus University. Now, at the same time, we have seen, because of widespread specialized production of monogastrics that cannot use grass products, we have all over Europe landscapes that are dominated with annual crops. It might be that they include rapeseed in their cereal cropping systems, but they're very specialized and simplistic, and not producing a lot, and not using land and soil, land and sun very efficiently. But with the biorefinery technologies, we could actually use more perennial crops and refine and take out high quality proteins that we can use to replace soybean import, for instance, for pigs. We have demonstrated that recently at Forum. So, but I'm curious if that's, so we can use a lot more grass, which would have benefits in terms of nutrient cycling and reducing leaching. It's better for biodiversity than the annual crops, etc. There's just so much synergy there. I just wonder, is that a model that you can see more also in Central Europe and in Southern Europe? And would it also improve water cycling and so on? Or what would be the limitations? Grass might not be suitable everywhere, but could it be other perennial crops and biorefinery? I like that in your triangle, because the crops that you mention are kind of traditional crops for traditional purposes, but you did mention biorefinery.
Okay, so I think for both questions we start with Eric, and then the other speakers can add.
Yes, what was our first question again? Because
I'm sorry, I distracted you.
On the uptake by farmers?
Of nutrient cycling.
Uptake of technology.
So the uptake by farmers of nutrient recycling technology, was that the question?
Yeah. Yes.
Huh?
The obstacles.
Why is it low?
The upstairs. Ah, yes. That was, the main barrier. That was the question. Yes. Well, I had parked it somewhere, but it's parked far in my brain. No, I think that for the last decade or so, a very big barrier used to be, and I say used to be, legislation. As of the start of the previous European Commission, they have made circular economy as a big issue. It was their main point. And when we had workshops with the Commission starting in 2013, we had an entire listing of European legislation that counted as a barrier for fertilizer or nutrient recycling. To just give one, and that it has been published now, the fertilizer regulation revision has passed, which is splendid by itself. But in the original one from 2003, there in the first chapter, it was already automatically excluding all mineral fertilizers which were not from chemical origin. So everything from plant and animal based was excluded. So that was not creating a level playing field if you had mineral fertilizers to be used. Now the legislation will allow that. Along the way, we have also identified potential constraint that would have on REACH legislation, waste framework directives, byproduct, and so on. And now also the nitrates directive, we think it might be up for a revision or at least a good assessment. And there is actually a 2-year trajectory within the Commission with GRC leading it to assess potential nitrate directive revisions or interpretations there. So if you ask me, I think the technological availabilities also to the farming communities had been ahead of legislation. Legislation has been catching up to the level that now I think we can move to actual implementation throughout Europe. So if you ask me what was the main barrier, it was legislation. It is now being tackled, so I'm looking forward to actual adoption.
Maybe if you other two you would like to address Neil's question more on the transition from annual to perennial and towards more forest trees in agriculture.
If we start with the crop, you're right. I mean, there are landscapes that you can only see grass all around. But that's also because somehow it's the easiest. And maybe the economical option. Even now with the CAP, we have there is the conditionality that obliges to diversify their land, and no, you have to. It depends on the size. You are obliged. But even this policy is not really working. So first we have to provide alternatives that at the end provide a way of living for the producer. That's the main thing. If there are still legumes producing very little, or rape seeds that are so hard to get it into the soil, or also for the south, if you have no water, you are obliged to use crops that can deal with the water it's available. It's different if you have irrigation. If you have enough water, you can have much more diversified system. But even in this case, there are, for example, some short season crops that are now being trying to improve, to facilitate, to have more diversified. When you go to trees, if you have little water, it have to be really sparse for the trees to grow, and then what you have in between, it's not easy. I mean, you might have a cover crop, but you have to kill it, otherwise it will compete for the water. So it really depends on, I'm confident, I'm optimistic that we can find more diversified system, but we need to work, and we need to work with the farmers, we mentioned before, participatory research, but we need to provide systems that at the end give not only money for that year, but also for the future generations, no? So.
Yeah, just I was not asked, but I can always respond. Just to add on this, I think it's a super interesting and important point, this sort of knowledge transfer to farming and forestry practice. And perhaps two things. First of all, I think it's really important also to let sociologists and people work with the ones doing farming, doing forestry, with landowners, with foresters, with administrations, to understand how they think and what their demands are. And I think this is really important. But to really bring this together then with people that work on the, let's say, technology, natural science research side, and to facilitate this, to create this understanding. And we cannot assume, and I think this is a lessons learned from political science, from sociology, that simply doing a law is meaning implementing it. We have been doing a lot of research on EU directives in the past, where really, if you look in what is happening between the trees, it's an own reality, and this is the state of knowledge in political science, so to say. It's really important to take this on board. And the second point, coming back to technology, I think technology can help there. We have one fancy thing, I would like to say 3 or 4 words on it, where there's always the question in continuous cover forestry, what tree do you basically cut, and what tree do you leave, and what tree is important for biodiversity, what is the economically available tree. And we have been setting up a system, colleagues of mine in EFI, where we do these demonstration sites, where we inventory every tree, and then we give an habitat value, biodiversity value, and an economic value to the trees. It's all on an iPad, and the forester can go out, and they can play the selection process. And it's not only a forester, you can do it with citizens, you can do it with policymakers, you can try it as a scientist. And then it's meanwhile in more than 17 countries, and it's really interesting, because in a playful way, you're solving one of the biggest trade-offs and discussion points in forest management, biodiversity and economy. And the results are really interesting. It's self-evaluatory. You can use it even for research. And this is, for me, a nice way, coming more from the sociology point, where technology can enable transfer or communication.
Thank you very much. We should maybe, it's next session, do something interactive like that. Okay. I'd like to almost close now. My colleague Leonora will try and summarize some slide contributions, just to say that whatever we couldn't cover, or if there's, I don't know, it will be all kept and feed into the reporting. And yes, please.
Well, interactions on Slido have been quite, silent. So we have 2 more questions, one for Georg and one for Eric. So the one for Georg would be, what could be the potential of renewable bio-based resources from forestry, and here particular non-wood products? And for Georg, it's about how can we understand what water-based measures and how what role they can play in helping to mitigate the loss of nutrients, while looking at the impacts, obviously, of excessive nutrient use on ecosystem effects, and linking terrestrial and aquatic systems.
Yes, so we'd like to take them. We're a bit over time. We're lucky in the sense that I think there's no other session after us, so we can take these 2 answers. And please, just 1 minute. The first one is probably to
the first
Georg.
question on non-wood forest products. I think I quoted this very recent finding based on an EU project that are now being published, that 26% of the European households are engaged in collecting non-wood forest products. So we are talking about berries, about truffles. They are part of Europe where forest management is primarily, in some regards, looking into that, mostly in Southern Europe, I think. And that has a this economic value, which I found quite striking being in forestry since a long time, 70% of the economic value of roundwood removal. So this is new research on that. And I think there's a big gray and informal area behind this. And it would be really interesting to dive deeper. On one hand, I mean, if more than 25% of European households engage into it, it means a big link from society towards forest. But there's also perhaps a hidden economic potential with these non-wood forest products that needs to be uncovered, because the value chains that come behind, as far as they exist, they can be quite high-end forest-related products. And I can make a connection, Dimitros, to colleagues of mine who have been working on this a lot.
Okay, so I think reading again the last comment here, it's more a suggestion for a mission. We don't need to reply really to this. It's just a very good idea.
Can I briefly reply?
But if you want to comment, yes.
Because I think it's a very good point. And I'll give you one example on where it's already happening. For example, in Scandinavia, you have new developments on macro algae production, so of the fjords, and by that they are removing nutrients out of the water, of course, in estuary systems. This also allows to mitigate effects, for example, from salmon production in those fjords. And there are indeed developments there occurring, and I do see that as a good way if you move more into the marine environment for those type of productions. But rather than use those types of productions to further eutrophy, to decontaminate waters which are rich in nutrients by producing such new types of agriculture. I think it is happening. It is happening in practice, and I think it's a good development. Yeah, okay. Good point.
So I think it has been a really, really nice and rich discussion. If you could show the last slide. This is not over now. So as you know, there was a public consultation that was extended on the strategic program, and voila, it has been extended until the 4th of October. So if you have any comments on the whole program, not just cluster 6 and this area, but anything, you can still comment either on the things we suggested or the other things. So please take the chance and spread this information in your communities. And with this, I'd like to come to the end and maybe have a last round of applause for 3 really excellent speakers, Elena, Georg, and Eric. And thanks to you.
Thank you.
Thank you.
Thank you. Thank you.